Hi, in this video we're going to talk about solving compound inequalities. The first couple examples, the directions we say to write this in interval notation. Let's start with a graph. X is greater than or equal to -2 and X is less than 4. That means we want the numbers that make the first inequality true and the second inequality true. So we're going to put -2 and +4 on our number line. If we want the numbers that make both the first inequality true and the second inequality true, we want the numbers that are greater than or equal to -2 and that are less than 4. That happens to be the numbers in between -2 and +4 that are shaded. And in general, and statements do represent shading in between the two numbers. Not necessarily always, but very likely that it is. So using what we know from the previous video, for greater than or equal to, we're going to use a bracket on the -2. And we do not have the equal to with the 4, so we're going to put a parentheses. To write this answer in interval notation, we're going to write a bracket, -2, comma, 4, parentheses. If the directions asked for set notation, or if they gave you a box to enter that looked something like squiggly bracket X, then with a line, squiggly bracket to finish, that's writing this how we showed in the previous video. We want the numbers between -2 and 4. So we're going to write -2 is less than or equal to X is less than 4. In other words, we want the numbers X that are in between -2 and 4. If you're going to write an in-between statement, these always need to be less than symbols. You're not going to use greater thans. For this next example, we want the numbers less than 1 or greater than or equal to 3. Put those numbers on your number line. For an OR statement, we want the numbers that make one of the inequalities true or the other inequality true, or both of them true, but only need one or the other to be true. So for X is less than 1, we're going to put a parentheses on your 1 and shade forever to the left, because those are the numbers that are less than 1. Or X is greater than or equal to 3, put a bracket on the 3, shade forever to the right, because those are the numbers that are greater than 3. If we're going to write this answer in interval notation, this first portion is shaded all the way until -infinity, forever and ever and ever to the left. So we're going to write -infinity, comma, this first piece stops being shaded at +1, so we'll write +1. Infinities always have parentheses, and our +1 here also has a parentheses. Because there's this gap in the middle where there's nothing, we're going to put a union symbol before we start writing our second interval, which starts at 3 with a bracket, comma, and this right part is shaded forever to the right until +infinity, which always gets a parentheses. So notice that this OR statement ended up as two separate intervals pointing in opposite directions. Usually OR statements will be pointing in opposite directions like this. Again, technically not necessarily, but usually. If you wanted this in set notation would just have a squiggly bracket, X line, like that. So nothing terribly interesting there. Now we have a couple examples where it says to actually solve the compound inequalities and to write your answers in interval notation. For this first inequality, notice that it really has three parts, a left part, a middle part, and a right part. When you've got three parts like this, it's going to be your AND statement, like we had here at the top. So to solve this, your goal is to get x by itself in the middle between the two inequality symbols. Well, how to get x by itself? You start by getting rid of this plus 1 by subtracting 1. But now we have to subtract 1 to all three sides, or all three parts. Once we subtract 1, we'll have negative 8 is less than 2x is less than or equal to 10. And now our goal is still to get x by itself in the middle. We're going to divide all three sides by 2, leaving us with an answer of negative 4 is less than x is less than or equal to 5. Directions, though, say they want the answers in interval notation. So we're not in interval notation yet. Once you've done enough of these, you would be able to figure out interval notation directly from what we have already, but let's graph just for practice. Put the numbers negative 4 and 5 on your number line. We want the numbers that are in between negative 4 and 5. So we're going to put a parentheses on negative 4, a bracket on 5, and shade in between those two numbers. To write this in interval notation, we're going to write parentheses negative 4, comma, 5, close your bracket. And for our last example here, we're solving an OR statement. To do this, we're going to solve each inequality individually, just like we would otherwise. So for this first inequality, to get x by itself on the left side, we're going to add 2 to both sides. And then we're going to divide both sides by 3 to get a final answer that part of x is less than or equal to 2. For the second part, we're going to subtract 3 from both sides of the inequality. Divide both of the sides of the inequality by negative 1. Remember that when you divide both sides of an inequality by a negative number, you need to reverse your sign. So that ends up as x greater than 7. We started with the word or. We're going to finish with the word or in between. If the answer was okay with you writing like this, it might give you these squiggly brackets and then a box to fill in inside them, or not. That is okay, but we're not really in interval notation yet. So in interval notation, let's do a graph. Put the numbers 2 and 7 on your number line. For the numbers that are less than or equal to 2, I'm going to put a bracket on 2. Less than or equal to 2 is shading to the left forever. the numbers that are greater than 7, put a parentheses in the 7, numbers greater than 7 are shaded to the right forever. So to write our answer in your interval notation, we'll have the first piece is shaded all the way from negative infinity until you get to 2, with a bracket, nothing in the middle here, so we put your union symbol. The shading starts up again at positive 7, so parentheses 7, comma, infinity, because this is shaded forever, never, never to the right. That is it for this video, where we solved compound inequalities. Thanks for watching.